zeros and ones, I'm making them flip. Got the N and got the O, R, XORs in the mix. It's a binary party, gonna teach you some tricks. With a flip and a shift, gonna show you how. Move those bits from left to right now. Set them high, clear them lower on the track. Let's learn Bitwise, there's no turning back. It's the Bitwise boogie whipping, we're sticking tight. Or sets the bits, makes everything just right. X-Boys flipping knots, got the show. In the binary world, we're the kings of the code. Left shift's a multiplier, making numbers grow. Move them to the right, and the values start to slow. Unsigned shifts clearing out, it's always filling zero. In the binary world, we're the kings of the code. Put your mask on tight, we're gonna clear and set. Extract those bits, it's as easy as it gets. Set the flags, toggle through, we're feeling strong. In the JavaScript jungle, we're big dancing all along. It's the Bitwise boogie whipping, we're sticking tight. Or sets the bits, makes everything just right. X-Boys flipping knots, got the show. In the binary world, we're the kings of the code. In math games clever, we're taking control. Clearing bits, setting how we're on a roll. Whether flags or data, we know what to do. With a Bitwise move, we're coding like pros, it's true. It's the Bitwise boogie whipping, we're sticking tight. Or sets the bits, makes everything just right. X-Boys flipping knots, got the show. In the binary world, we're the kings of the code. So when you're in JavaScript, you need some Bitwise love. Remember these operators, they fit like a glove. Flip, mass, shift, and more, you're ready to ride. With the Bitwise boogie, you'll code with pride.
All right, here we are back in Visual Studio. So we are going to talk computer systems. Numbers are represented in binary. When you get down to the hardware where you're talking about transistors, it is all either 0 or 1, true or false or whatever. And that's really where we get this idea that binary numbers are important in computer programming. So binary numbers only use 0 and 1. We're typically used to the decimal system, which uses digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But as I said, in binary we only have 0 and 1. So for example, you might have a binary number 101. And that equals 5 in decimal, and here's how we evaluate that. We say 1 times 2 to the 2, 0 times 2 to the 1, and 1 times 2 to the 0. So each digit going from right to left is worth 1, and then 2, and then 4, and then 8, and then 16. And notice that each one of these are powers of 2. So let's let the rubber hit the road. Here I've created a binary number, and you can tell Visual Studio it's binary by preceding the actual binary value with 0b. And this is that value that we used up here. That example here. And when you do a console.log, it's not going to output as a binary, it's going to output as a decimal. And run it, get a 5. So here's another example that's barely above the treetops here. So here we have that value of 5 again, and now we have a value of 6. Notice this is 1, there's not a 1, but this is 2, and this is 4. So 2 plus 4 is 6. Remember, it's to the 0 power, to the 1 power, to the 2 power, and so forth. So now we add them up, and when we do console.log, it's going to show you the decimal value result. You can convert a binary number to a string with this toString 2. So I'm going to comment that out because it'll give me an error. So the example I have now here is we're going to let this decimal number be 23. We're going to convert that to a binary string by using that .toString 2. And then we're going to output it as 10111. Now, that's a value of 1, that's a value of 2, that's a value of 4, we skip the 8, and that's a value of 16. If you add all those up, you're going to get 23. So let me go ahead and run, and that's exactly what we get. So you can convert a binary string back to a decimal number using the parseInt function and use a radix of 2. Here's an example. Let binary string equals 10111, and we already know what that is. That's 23 in decimal. But we use the parseInt function here. We give it that string, and then we say use a radix of 2. And radix of 2 actually means the base of the number. Like our decimal is base 10, binary is base 2. And then if we output it, it's going to output 23. So here we go. Okay, so here's another example based on that. Let me say sum here. I think up above we use a variable sum. Okay, binary A equals that. That's going to be 5, right? This says to JavaScript that this is a binary number. This says to JavaScript that's a binary number. Here's the value of 1. We skip 2 plus 4. That's 5. All right, so now we're going to add them up, and we just output their sum as a string. And now I have a subtraction problem. Okay, so here we have this says binary value, this is going to be 11, this says binary value, and that's going to be 5, difference equals A minus B, and finally we do a console.log and we do a difference.toString with a radix of 2. Here we go. So JavaScript supports several bitwise operators that work directly on binary representations of numbers. Here we have a bitwise AND, a bitwise OR, bitwise exclusive OR, bitwise NOT. And this isn't really bitwise. This operates on whatever the entire number is, or the entire register if you're working on a hardware level. So left shift and right shift. So here's an example. Here I have binary A is 10 in decimal, binary B is 12 in decimal. What I'm going to do is perform a bitwise AND between those two variables, and that will be put into result, and what will happen is it will output 1000 binary, 8 in decimal. Now the reason it's doing that is because it looks at every bit, and every time there's a bit in binary A and binary B, the result will be that bit, right? So if it's a 1 and a 1, thus the word AND, the result will be 1. If it's a 1 and a 0, or a 0 and a 1, or a 0 and a 0, the result will be 0. So to summarize that, bitwise AND compares corresponding bits of the two numbers and returns 1 if both bits are 1, otherwise returns a 0. Binary numbers are often used in setting flags. This is where each bit might represent a different option or setting. You can use bitwise operators to manipulate these flags. So here I have a flag read, a flag write, and a flag execute. And notice they're all binary numbers, and this is 1, this is 2, and this is 4. If you just look at the digits, you can easily see that. So I might do something like this. I'll paste in let user permissions equals flag underscore read or flag underscore write. Basically what that's doing is combining these two values, this value and this value, and what you'll get is a 0, 1, 1. Then you can do kind of a reverse process to see if someone has a permission. So for instance, I'm going to take whatever is in the user permissions. I'm going to AND it with flag execute. And if I do have flag execute set, then I will get a non-zero value here. So go ahead. And I get a 0 because I didn't have that set. Notice I didn't have it set here. Had I done a flag read, I would have gotten a different value. Okay. So I created several functions that will be useful for this part of the lesson. What they do is they take two numbers and perform an operation and then show you the results. So if I say AND two numbers, 1, 2, 3, 4, 5, 6, and run that, it will show you, here are the two numbers it's going to AND. It's got a little title, and then it goes ahead and shows you the two numbers in binary. And then once they're ANDed, it shows you them. And once they're ANDed, it shows you the results. So here I only have one bit that is set, so the result will be 0. Here I only have one bit that is set, the result is 0. Here I have no bits that are set, so the result is 0. And here I have both bits that are set, so the result is 1, result is 0, result is 0. Here both bits are set, so I have a result of 1. And here I have a result of 0. Now it also shows you the decimal value of the result too. So let me just make this an OR and run that, and you'll see that if I have any bit set, the result is 1. If I have no bit set, the result is 0. And so you can see the results. Almost everything here is set except for this particular bit here. And the decimal value is 507. The last thing, let's go ahead and change it to XOR. And save and run that. And here are my results there. Now, I would like to show you, we have this thing called a truth table. And if you've had like discrete math or something, you probably have already seen these. And so the AND truth table looks like that. So the only time you're going to have a result of 1 is if they're both 1. The OR truth table looks like that. The only time you're going to have a 0 as a result is when no bit is set. And XOR actually really is kind of a toggler. I always think of it as toggling the bits. So in the lesson PDF that is on the server that you can download, I've included all the truth tables and the functions that I used at the very end of the document.